The line joining the ends with the point P, let them subtend an angle alpha and beta with horizontal. This particular thing will subtend an angle. Okay, let this be dy. So what is the current element? Current element will be high into dy. And look at it, it's a finite wire, no? Not long wire. So alpha and beta are angles subtended by this. So let this be the angle between the current element and the position vector. So this will become, let me write d, let me r. So this will be the angle, no? So here it will be theta. And let me call this is phi. This is d theta. Okay, now we have to get expression for the magnification at point P due to this finite wire. So at what is the small d? Perpendicular distance measured from the long wire. So from the directly, let me enter into the Biot-Savart law. So what the Biot-Savart law says, dB equal to mu naught I dy. What is y? Let me assume that this equal to 4 pi. At what distance the current element is from point P? At a distance r. What is the angle between current element and the position vector? Look at this one. This I bar, this is r bar. So what is the angle? Angle is theta. So therefore this will become sine theta. Is that okay writing this one? I dy sine theta, you have to write it. So if I directly go for integration, what is the problem? R is variable, theta is variable, dy is variable. So I should search for any suitable mathematics where we can bring answer, we can express only in terms of alpha beta. Angles subtended by the ends at the point P with horizontal. So with that what happen, we can easily determine the magnetic field at point P. So here, first we'll begin like this. So we should replace the theta, we should replace theta, then theta plus phi so sine theta I can replace in terms of cos. So first one replacement got over from this. So theta equal to 90 minus phi. Okay, there's a one replacement. Then again we have to replace r also. We have to replace r, and dy also has to be replaced here. So sine phi, let's see that sine phi is equal to tan phi. Tan phi equal to y by d. So y equal to d tan phi. Differentiating this, dy equal to d secant square phi d phi. So dy, I'm able to replace that one. Now what about the r? So cos theta, cos phi equal to d by r. So r, what you can write? D secant phi. So let me substitute all these things. So dB is equal to mu naught I dy will be d secant square phi d phi, 4 pi r square will be d secant square phi. So sine phi, so sine theta, sine of 90 minus phi. So secant square get cancelled. So mu naught I 4 pi d cos phi d phi. Now what should be the limit now? The limit here d phi is what? This particular d theta. Okay, this I think I'll write it here. This is what needed for us. Now, as I vary d phi from 0 to plus alpha, I'll get the field strength at point P due to upper segment of the wire. If I vary the d phi from 0 to plus alpha, I'll get the field strength at point P due to upper part of the wire. If I vary the d phi from 0 to minus beta, you see the sense of rotation, minus beta, then I'll get the field strength at point P due to lower part of the wire. So therefore the limit will be minus beta to plus alpha. So this will be mu naught I 4 pi d just do remember next week, like when we go to the some next topic, no, so these data is very important for us. Many problems are linked with this mixed concepts. Plenty of numericals are related to this one. That's why I just picked up this one. So there's a what are alpha beta angles attained by the line joining the ends with the perpendicular distance at the point P. In SE Verma, yes, took alpha beta here. Then you'll get cos alpha cos beta. The formula is same. In SE Verma, instead of alpha here, he has made this as alpha. This is beta. Then you'll get cos alpha cos beta. This is due to finite wire. What about the direction? What about the direction at point P? This is field at point P. What about the direction? Will be out of the plane. If you here how the field will be into the plane. So the same method what we have in electrostatics, no, the same similar approach will be there. There the point charge, here current element. There the charged body, here current carrying wire. There it was the Coulomb's law, here Biot-Savart law. There it was the Gauss law, here Ampere's circuit law. The same concept, electric pressure, here magnetic pressure. Almost all the set of numericals will be same. Okay, just hold the wire in your hand and put thumb in the direction of current. The fingers here will be into the plane. Here the fingers will be out of the plane. That's all, no? Right hand thumb rule. The field here will be into the plane. The field here will be out of the plane. Now, after this, we'll go for due to long wire. Other things will go for further. Already took 1 hour time. Due to long wire, what is alpha beta?